So the problem we have is that z is equal to minus 6 plus 6i, and we need to calculate arg z, giving your answer in radians to 3 decimal places. Minus 6 looks something like this, minus 6 plus 6i, so that is minus 6 plus 6i. And we need to find the arg of z, which is this angle over here. To get that angle, we know that the opposite must be 6, and the adjacent must be 6, so we can use tan theta to do so. Now, if that is the case, and we're going to work that out, then it's not too challenging to write out something that looks like that. So arg z is tan to the minus 1, 6 divided by minus 6. This does give you 2.356. Another mechanism another thing to be aware of, however, in order to get this value, is if you were to just do tan 6, then the angle that you'd get would be this angle in here, like so. And so what you would really need to do is pi minus that angle, pi minus this little angle to get what we need as arg z. The second question says, and by the way, that is 2.356. So the second question says the complex number w is given by w equals a over 6 minus I, where a is a positive constant. So, and we've been given that the length of w is root 333. So one thing to go about fixing this is to recognize that we can calculate the length of w, or we've been given the length of w, but you can also make a calculation about it. So let me show you what that means. That means if I were to find this length of w, then I'd need to find the length of this a, which is a constant, so it's just going to be a, and I'd also need to find the length of 6 minus I, which is going to be 6 squared plus 1 squared square root using Pythagoras' theorem. That is to say, we know that the real part is 6, the imaginary part is minus 1. I can then consider this as a Pythagorean triangle. 6 squared plus 1 squared will give me the largest size of that triangle, or the hypotenuse if you're considering the angle in here. So that is what we're going to do. So what you will see here is, first of all, the a, this a, is just being kept as a because there's no point in considering a constant. If a is a positive constant, then there's no point in considering to what extent the modulus of a is something different. 6 minus I, 6 squared, 36, plus 1 squared square root 37, so that is why we have root 37 under here. And we know what the modulus of w is. The modulus of w is root 333. With a little bit of rearranging, you'll get a is equal to 111. So in other words, multiply both sides by root 37. Since a is equal to 111, and in any situation where you're trying to find something in the form a plus ib, then what we need to do here is multiply by the complex conjugate of the denominator, which we will have seen we done in many other situations where I'm talking about something that has a complex number underneath. You multiply top and bottom by the complex conjugate, or a different sign in here, in order to sort out the i's in the denominator. And as a result, you'll end up with, given that we know a is 111, this has come from the fact that we know a is 111 as calculated earlier, then with a bit of multiplication, 6 times 6, 6 times I, plus minus 6 times I, plus minus I times I, where an I times I is minus 1. So as a result, you multiply the minus sign again, so it produces 1. A little bit of maneuvering around, and you end up with 18 plus 3I. Next. Finally, calculate arg w equals arg z. Arg w equals arg z is the same as arg w minus arg z. Now, the one thing to be aware of here is it does look as though it means the difference, and its magnitude will be the difference, but the direction can often be a little bit odd. We know, let's make sure that we can see what w looks like. W is 18 in terms of the real. So w here would be 18 over here, and it is 3i. So something like that is what w looks like. This here is our original z, and we need arg w divided by arg z, which is the same as arg w minus arg z. So how would I calculate this? I'd calculate this by simply doing arg w, which is this angle here, and then, remember, it's from the real up until this point, never goes past 180 degrees. And then what I would need to do is turn around the minus sign turn round and produce the correct size of arc Z. So I move to arc W, there's arc W done, then minus, which is the equivalent of turning around, and then doing the size of arc Z, which we know arc Z is this here. So imagine if I moved arc Z round, it would go to here, something like that. And let's not, just to use the, let's say for example, that is to say that this angle here, arc Z, is this angle here, arc Z. So arc W minus arc Z could be considered to be arc W minus arc Z. And then, therefore, the angle that we're looking at will be sitting on this plane at that angle there. So this angle here. And so you can see the working of this. Arc W divided by arc Z is arc W minus arc Z, which is the same as tan to the minus 1, 3 over 18, which is this one, tan to the minus 1, 18, 3. So again, tan to the minus 1, opposite is 3, adjacent is 18. Take away, so take away, which means once you've moved to this point, you take away and then you add the arc Z, which you know is 2.356 as stated earlier. And so we are doing it here, minus 2.356. This puts us at minus 2.191 radians, and that will do for now. Thank you for your time.